Hey there, y'all. Today we're going to look at 3.4 on equations in two variables. Our objective is to explore the relationship between the solutions of an equation in two variables and its graph. Our standard that we're looking at is AREI 10, and this is to explain that the graph of an equation in two variables is a set of all its solutions plotted in the coordinate plane. And so we're going to look at that in this section and section 5, and as we go into unit 4 next unit. So as we look at a couple of definitions here, remember that equations in one variable will typically have one solution. Remember, there are some special cases where this would have no solutions, or also have infinitely many solutions, right? And we talked about those cases in Unit 2. Now, equations in two variables will usually have infinitely many solutions, because when we look at these solutions, we're not talking about getting it and just getting one individual point on the coordinate plane. When we talk about this equation, we're talking about multiple points across that will create some type of line or curve that will become all of these points across the coordinate plane that we'll get for our answer. And so what is a solution of an equation in two variables? Well, as we look at that, that is this. A solution of an equation in two variables is any order pair, x, y, that makes the equation true. Okay, so again, a solution of an equation in two variables is any order pair, x, y, that makes the equation true. And so we're going to look at some examples of what that means in the first example. So in example 1, we're looking at, given an ordered pair, is that ordered pair a solution to the equation given? And so if we're given an ordered pair, remember that the first part is our x, the second part is our y. And so when we substitute that in, we're going to get 3 times 8 plus 5 times 1. Is that equal to 15? And so we're going to do our order of operations and see if this statement is true or if it's not. And so 3 times 8 is 24, and 5 times 1 is 5. And so 24 plus 5 is 29. That does not equal. And so the order pair 8, 1 is not a solution. It is not a solution because it did not come out true. Whatever we're looking for is going to say like 15 equals to 15 in this case. And if we get anything different, it's not a solution. Okay? So let's look at example B. In example B, we're given the same equation, 3x plus 5y is equal to 15. But now we're going to try the order pair 0, 3. Let's see what happens. Remember that the 0 is our x, the 3 is our y. And so we're going to do 3 times 0 plus 5 times 3. Is that equal to 15? And so 3 times 0 is 0, and 5 times 3 is 15, and 0 plus 15 is equal to 15. So this checks out. So the ordered pair 0, 3 is a solution to this equation. Okay? So again, we're trying to see if when I substitute in for the x and the y, do I get the right side? Or if it's solved equal to y, do I get that the left is equal to the right? Okay, that's what we're looking for in these examples. Let's look at the next two examples in C and D. In example C, we've got x squared minus y is equal to 23. And we're checking the order pair negative 5, 2. So let's see what happens. So remember that this is our x and this is our y. And so remember when we substitute, we want to use parentheses. So negative 5 squared minus the 2, is that equal to 23? Well, when we substitute that in, so negative 5 squared is positive 25 minus 2, and 25 minus 2 is 23. And so this checks out. So negative 5, 2 is a solution to the equation x squared minus y equals 23. Okay, so let's look at D, and I want you to try that one on your own. So let's go over there. So on D, x squared minus y is equal to 23, and I want you to try the order pair positive 5, 2, and see what you get. So pause the video now. All right, so in x squared minus y equals 23, let's see if you got this right. Remember that the 5 is our x, the 2 is our y, And so substituting in, we get 5 squared minus 2. Is that equal to 23? Well, 5 squared is 25 minus 2. 25 minus 2 is 23. So it checks out. And so 5, 2 is a solution. And so we just found 2 different ordered pairs that are a solution to the same equation. And we will actually find many ordered pairs that are the solution to these equations. Okay? So let's look at now how we can deal with this further. So in example 2 here, we're going to graph an equation. But before we can graph it, we need to get some ordered pairs to put on the coordinate plane. And so let's look at some values that we're going to substitute in to see this graph. Okay? And so we're given the equation y equals x plus 2. And you can see we pick out some values here from -2 to +2, and we're going to find what their y values are. And so we substitute in -2 plus 2. Well, -2 plus 2 is 0, so we get the ordered pair -2, 0. And so at -2, 0, I'm going to put a point. And then we do the same for -1 plus the 2. -1 plus 2 is 1, so we get -1, 1. And so we plot that point. And we're going to continue this pattern. So I'm going to pause the video, do the rest of these. I want you to try those on your own as well. Figure out these ordered pairs, and then come back and we're going to see all these plotted up. Alright, so I've written out the rest of these ordered pairs here, and we've also plotted these points on the coordinate plane here. So that's what your graph should look like at this point. Now, here's what we need to understand, is it's not just these integer values at work. Because I could plug in a decimal here. I could plug in 0.5 for x, and I would get 2.5 for y. And so when we draw this, it's not just these points here, but the line that will continue forever in the same direction. And so we can continue these points along the same path because this is a pattern, and what we end up getting is a line that looks like this. That's the whole point of this, is that in the end, all of these points make one continuous line, because all of these ordered pairs that are along this line, fractional, decimal, whatever, will be solutions to this equation. And again, it doesn't matter if it's a nice fraction like 1/2 or a complicated fraction like square root of 5. Okay? We could deal with any of those and find what the y value would be. Okay? So last problem we're going to look at is a application problem. We're going to look at a word problem here and see how this affects what we do on the coordinate plane. So let's take a look at that. So in example 3, we see here that Johnny is planning a group outing to play laser tag. The cost of the outing, represented by y, can be modeled by y equals 25x plus 10, where x is the number of guests. We want to complete the table and graph the equation. Now, we need to remember that, can I have half a guest? No. And so when we graph this, we've got to think about, does connecting the dots make sense? Now, a lot of graphs we will connect the dots, but we need to pay attention to the patterns here. So let's see what happens. So at y equals 25x plus 10, if I have 2 people come to this party, it's going to be 25 times the 2 added to 10. Well, 25 plus 2 is 50, and plus 10 gives us 60. And so that's the order pair 260. And what does that mean? If I bring 2 guests, it's going to cost what? $60. Okay? Let's see what happens with 5 guests. So 25 and 5. 25 times 5, and then adding 10. So 25 times 5 is 125. Adding 10 gives us 135. So this would be 5 guests and $135. Let's try it for 8 and 10. So pause the video and try those two and see what you get. So we see here that when we plug in 8, we get 210. So that means if we had 8 guests, this would cost us $210. And if I had 10 guests, this would cost $260. So now we want to graph this on the coordinate plane given here. And so obviously if we count by ones, we're never going to get to 260. We're going to be counting forever. And so we need to use our coordinate plane wisely so that way we can graph this appropriately. So let's take a look at what we're going to do. Now our x values we can count by 1. So this would be 2, this would be 4, this is 6, 8, 10, and so on. That's our x, which is the number of guessed. So for our y-axis, what we're going to do, which our y is the cost, we're going to have to count by something other than 1. And so we could count by 20. So this first line is 20, and then 40, 60, 80, 100, 120, 140, 160. This would be 200. This line is 240. This line here is 280. And the very top of the graph would be 300. Okay, so let's plot these points on the coordinate plane. 2 and 60, so that's pretty easy. That's right here on this corner here. 5 and 135, so this is 120, so this middle line is 140, so we're a little below it. 8 and 210, so it's going to be right here in the middle here. And 10 and 260 is right here. And so if we look at those 4 points, it looks like it makes what again? Well, I could probably take a ruler and make those 4 points lie on the same line. And so we can connect those dots like so. Now, again, would a fractional value really be a solution here? Can I have half a person? No. And so we could graph this with just points, but the line shows us all the possible values, and then we could restrict the domain from there. All right, so that is it for this lesson. Don't forget to fill out your Google form. Make sure if you have any questions, put those into the Google form, and I will catch y'all next time.